McKenna, and this is my Chapter 18 reassessment video. The question goes as follows. What is the equivalent resistance between points A and B? Part B says a 276 volt of electric motive force is connected to terminals A and B. What is the current in the 12 ohm resistor? So to solve the first step of the equation, from the diagram we see that the 12 ohm resistor right here and the 24 resistor are connected in parallel. So the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of each resistance. So we have to set up the equation like this. So we get 12 ohms times 24 ohms divided by 24 ohms plus 12 ohms, and that gives us 8 ohms. So we go down and it shows us, where is it? Oh, the 15 ohms up here at the top of this diagram. We add those together, 15 ohms plus our 8 ohms, and that gives us our 23 ohms. So therefore the resistance between points A and B is 23 ohms. So next, for part B, from the Ohm's law, the potential difference across the conductor is, right here, is delta V equals IR. So we have to mix up that equation, and I gives us delta V over R. So our delta V for our volts, well, it's the diagram's right here too. It's 276 volts divided by 23 ohms. So that gives us 12 amps. And then we go down and we have the diagram relabeled again, just showing us the current flow of each resistor. So this is our positive, and it's going this way. I2 is going down, and I is going to the left. So the equation to apply the junction rule is I equals I1 plus I2. So we have the equation right here, the I1 right here, that's 12 ohms equals I2, 24 ohms right here. And then we do a little algebra, I2 equals I1. So we do 12 ohms divided by 24 ohms, and that gives us 0.5 for our first I. And we come down, so we do 12 amps equals I1 plus 0.5 I1. And that gives us this, 1.5 divided by I1, it gives us 12A. And then to solve for that, 12A over 1.5, and that gives us 8 amps. So that that's the current flow in 12 ohms, and the resistor is 8 amps.